Choose all the relationships that are described by the following equation. Y is equal to 7/8 x. All right, let's look at these relationships. Relationship A. A bouquet of 8 daisies costs $7 at Flora's Flowers. A bouquet of 12 daisies costs $11. The equation describes the relationship between the number of daisies x and their price at Flora's Flowers y. So let's look at scenario A. So our x is the number of daisies, and our y is their price. Our y is the price. So when we get 8 daisies, they say it costs us $7. When we get 12 daisies, they tell us that it costs $11. So let's see whether this relationship right over here is the same as this relationship right over here. So if I were to take, so let me write this right over here. So here it says y needs to be equal to 7/8 x. So let's figure out what 7/8 x is equal to. So 7/8 x, so if I take 7/8 times 8, well, that's going to be 7. Let me write this down. 7 over 8 times 8 is equal to 7. So this checks. 7/8 x is the same as the price that they gave us. So far, these two seem consistent, at least based on this first data point. Now let's look at 7/8 of 12. 7/8 times 12. Let's see, if we divide 12 and 8 each by 4, this is going to be the same thing as 7 times 3 over 2, which is the same thing as 21 over 2, which is equal to 10.5. So if y were equal to 7/8 x, 12 daisies would cost $10.50, but we just learned that 12 daisies cost $11. So these two things aren't equal to each other. So this is not the same relationship. In this scenario, y does not equal 7/8 x. So we can rule this one out. Let's look at relationship B. There's a 12.5% discount for every item at Crazy Joe's. The equation describes the relationship between a given item's price before the discount and after the discount. So here they're giving us a percentage. And this equation right over here, it's written as a fraction. So let me at least convert this into a fraction and see what kind of a fractional discount this is. And maybe I can construct an equation and see if that equation is the same as this one here. So 12.5%. So 12.5 is literally the same thing. So 12.5% is the same thing as 12.5 over 100. And if we multiply the numerator and denominator by 10, that's the same thing as 125 over 1,000. Now let's see if we can simplify this a little bit. If we divide the numerator, by, well, actually, it looks like they're both divisible by 125. We divide the numerator by 125, we get 1. We divide the denominator by 125, we get 8. 8 times 125 is 800 plus 200, which is 1,000. So this is the same thing as 1/8. So there is a 1/8 discount for every item at Crazy Joe's. The equation describes a relationship between a given item's price before the discount and the price after the discount. So let's just think about that. The price after the discount, based on the information they gave here, is going to be equal to the price before the discount minus the discount. So minus 1/8 of the original price. Well, what's x minus 1/8 x? Or another way of thinking about it, what's 1x minus 1/8 x? Well, that's just going to be 7/8 x. So this relationship is the exact same as this one over here. The price after the discount is 7/8 of the original price. So we can feel good about this one. These two are the same. Let's look at scenario C, and I will do scenario C in orange. A ticket to the paintball arena costs $7 and comes with 8 paintballs. Every extra paintball costs $1. The equation describes the relationship between the number of paintballs x and their price y. So let's look at this. We'll do something similar to what we did up here. So we'll have x, which is the number of paintballs, and then we have y, which is their price, and then we will think about what 7/8 x would have been equal to, and let's see if y is equal to 7/8 x. So when we get 8 paintballs, so x is the number of paintballs, so when we get 8 paintballs, the price is 7. And if we take 7/8 x, so 7/8 times 8 is indeed 7. So in this scenario, for this data point, it is true that y is equal to 7/8 x. Now let's get a couple of other data points, and we might have to construct these. So every extra paintball costs $1. So if we have one extra paintball, so we have 9 paintballs, we're going to have to pay $1 more. We're going to have to pay $8. And so what's 7/8 x here? So 7/8 times 9. Well, we don't even have to compute it. This is going to be something. It's going to be like 63 over 8. 64 over 8 would be 8. So this is a little bit less than 8. But the important point is that 8 is not equal to 63 over 8. Y does not equal 7/8 x in this scenario right over here. So this equation does not describe all of these data points. So we can rule that out. Finally, they say the equation corresponds to the graph following graph. So let's see if y equals 7/8 x corresponds to this graph right over here. So what we're really saying is that for any x, y is going to be 7/8 of that. And the easiest one is to see when x is equal to 8. When x is equal to 8, 7/8 x would be 7. When x is 0, 7/8 of 0 will be 0. And it's a linear relationship. This tells us that this is, if we have a line, and if it goes through the origin, it is a proportional relationship, that the ratio between the x and the y-axis is always going to be the same, or that the y and the x, or between the y and the x values is also always going to be the same. And we know that that ratio is the correct one. The ratio of y to x throughout this line is 7 over 8. Here it literally is, the numbers are 7 over 8, but we can even take other points. The ratio of 3.5 to 4 is still the same thing as 7 over 8. So this relationship D, the relationship described by the graph, does coincide with the relationship described by this equation. So I would go with B and D.